Hey, yeah, sorry, I was muted. Actually, I'm having some tech issues here. My picture is completely frozen, and I don't know what is being seen at the moment. Jakob, I've added you to the stream, I think. Can you say something?
Yeah, I can see you
Okay, you can see.
and hear you.
What do you see on the screen?
I see the code of conduct
You see the code
and
of conduct.
ourselves.
Okay. Yes. Hey, hello, everybody. I'm sorry. This StreamYard is not really working for me these days. But yes, welcome to today's session. Fortunately I don't see my screen, so I'm just going to add Jakob, our speaker today, and his slides. Can you see that? Please confirm if you can see our speaker and his introduction slide.
I can see it at least.
You can see your slide.
Yep.
Okay, and you can see yourself.
Mm-hmm.
Okay, all right. Well, then I'm just going to, introduce. So yes, hello everybody, and I'm sorry about this. My name is Erika, and I'm the program manager at Microsoft Reactor Stockholm today. Today we are going to continue with the sixth and the last episode of the Cloud Native track in the Championing Azure Collection series. This series has been providing an introductory overview and is perfect for those that are early in their developer career. The code of conduct, you can't see that slide, but it basically is just that we all come from a different background, but we are all here to learn. So please be respectful and be please welcoming to all the questions and views. Thank you. Our speaker today, who I hopefully can see, is Jakob, or Jacob in English, but here in Sweden we pronounce his name as Jakob N. Jakob has over 20 years of experience with professional software development and currently works as a programming architect, specializing in DevOps and cloud architecture. Jakob is also Microsoft Azure MVP, and he's a former Microsoft ALM MVP and the Visual Studio ALM Ranger. He speaks regularly at various conferences and user groups around the world. In today's session, you will learn about Kubernetes services, a very powerful platform for running any kind of containerized workload, either on premises or in the cloud. Jakob will focus on Azure Kubernetes Service, the managed Kubernetes service in Azure that makes it easy to manage and scale a Kubernetes cluster in the cloud. The session is going to run for about 45 minutes, and we will have time for questions at the end. But yeah, I can encourage you to ask your questions throughout the session in the chat. So with that, I would like just to say a big thank you to Jakob for being here with us again today. You were here last week, so thank you for coming back. And I'm going to be putting myself in the background, and it's all on you now, Jakob. Thank you.
Okay. Thank you. Thank you very much for introducing me. Yes, my name is Jakob N, or you can call me Jacob if you want to. That's fine. So welcome to this last session in this cloud native track. This is the sixth and last session of this track. And as Erika said, I will be talking about Azure Kubernetes Service today. So again, my name is Jakob N. I'm a Microsoft Azure MVP, and I work here in Stockholm, Sweden, at a company called Active Solution. I'm an Azure MVP. I used to be a DevOps MVP, and have written some books in those topics, and I try to blog as much as I can and so on. So please follow me on Twitter and contact me through my blog if you want to discuss any of the topics that I'm talking about today, or anything else really. That's always nice. And if you are a software developer living here in Sweden, I urge you to contact us. We're always looking for talented people all around Sweden to join our company and work with Azure-related technologies and cloud-native things. So with that out of the way, let's talk about this session. So I'm going to focus on Azure Kubernetes Service, but we'll be talking about a few different things here. So I'll start with a little bit of introduction to Kubernetes in itself, which is a big topic, of course, but you must understand it in order to actually use the Azure Kubernetes Service. And then I'll show the service itself, and we'll dive a little bit into various topics around it, such as how does networking work? How can I send traffic to my applications? How can I scale the application? How can I monitoring it and make sure that it's highly available? So this is kind of an introductory session, so we won't go into too much detail of these topics, and maybe we'll have a more of a deep dive session later this spring on the AKS service as itself. So let's just quickly talk a little bit about what options you have for running containers in Azure. I showed this slide actually last week when I talked about Azure Container Apps. So first up, if you have a containerized workload that you want to run in Azure, the easiest one is probably the Azure Container Instance, which is a kind of a serverless container service where you can say, hey, run this container for me in the cloud somewhere, and then you just pay for the amount of resources that you use. So basically, you pay for the amount of time you're running a container. This is perfect for task-based things, for short-running workloads where you quickly want to scale out, for example, and then you can scale down to zero, and then you don't have to pay for it anymore. It's not really suited for like long-running things. Then you have the Azure App Service. This is the standard web service in Azure where you can deploy containerized workloads if you want to. So this is, of course, perfect if you're building web apps. So if you're just building web apps, Azure App Service is a great service for that. Last week, I covered a new player in the field, which is the Azure Container Apps Service. So this is still in preview, but it's got a lot of potential. So this is designed to let you deploy kind of microservice applications, a system that consists of many services. It could be web apps, it could be APIs, it could be background jobs, which will then run together and communicate with each other. And this really makes it very easy for you to deploy those types of applications. This is actually built on top of Azure Kubernetes Service, which is kind of the full beast. So Kubernetes is a very powerful platform, and you can do a lot of things here. You can run any kind of workload here, really. But it does require more knowledge. So getting started with it requires more, but of course, also the potential is very high here. So again, this is the service that we'll be talking about today. So let's just take a step back first and kind of talk about container orchestration, which is, it means that you have a containerized workload that typically consists of many moving parts, many applications. So you need a way to make sure that you can deploy and run these containerized applications on multiple servers on-premise or in the cloud. And there's typically some features that you want to have here. So let's just talk about a few of those. So, for example, what you want here is to be able to do rolling upgrades, meaning that you can deploy new versions without having any downtime. This is something that you will expect from this type of service. You want to make sure that you have health monitoring and self-healing in place. So making sure that your applications is healthy. And if it's not, you need a way to kind of restart your failed services. And you want to have a way to also to continuously monitoring your services to make sure that they are healthy. Load balancing and service discovery is very important when you have a multi-service application. Because the service needs to talk to each other, so they need to be able to find each other, and you want to be able to load balance traffic. So if you scale out your services to multiple instances, you must have some type of load balancing that can route the traffic to either of your instances. You also want to be able to scale, preferably dynamically. So depending on the load of your system, you want to be able to scale it up, scale out, and of course also the opposite, to scale down when the load of your application decreases. So there are multiple container orchestrators, but Kubernetes is the big one that's kind of won the war. So this is originally built internally by Google, and they open sourced it for 6 or 7 or 8 years ago. So and it's become a huge success, and there's a few reasons for that. To start with, it's a portable solution. This is implemented in Go, and of course this is a huge thing, which means that you can run this on any platform. And as I said lower down here, that this is also now supported by all the cloud vendors. So in addition for you to be able to run this on-premise, all the different cloud vendors such as Microsoft, Azure, Google, Amazon, and so on, they support Kubernetes, which means that you're not really locked into a specific vendor here. And this is one of the big things with Kubernetes. You can take your workload and you can kind of deploy it anywhere, really. And it's extensible, and this is probably, it's really extensible in a good way, which means that all the cloud vendors, for example, have been able to plug in their services behind the abstractions that Kubernetes implements or offers. So, for example, you can plug in, for example, Azure-specific storage in your Kubernetes application without your application really have to know any of the details. So all this means that you can take an application, you can deploy exactly the same application to, for example, Azure Kubernetes Service or to the Google Kubernetes engine, and you don't really have to change anything in your application. And of course, this is has a huge community around it. This is, I think, one of the top 3 most popular open source projects over at GitHub. So it's a huge community around it, and the tooling and the supporting frameworks around it just keeps growing and growing all the time. And of course, this makes for a really healthy project. So let's talk about like an overview of Kubernetes to get started here. So what you will also have when you run Kubernetes is what's called a cluster. So you create a cluster, and that cluster consists of master nodes and your working nodes. So a node is basically a machine here, a virtual machine running somewhere. So the master nodes, that's the kind of the brain of the cluster, which dictates a lot of things. And the working nodes to the right here, that's where you'll be running your applications. Then you need to deploy your applications to your cluster, and you do that by describing this in what's called a deployment manifests. And there's actually multiple types of manifests here, but the deployment one is the most common one. This is where you specify, for example, which container image to deploy, how many instances or replicas that you want to scale to. You give it environment variables and other types of metadata. So you take this YAML file, and then you basically send this to the master nodes, to the API of your cluster. And then the Kubernetes will make sure that it will instantiate the desired number of replicas. So in this case, I specified 8 replicas. And Kubernetes will now create 8 what's called pods. So pod is basically the same thing as a container. So inside that pod, your container will be running. And Kubernetes will now distribute your pods across all of these existing nodes by default. So to make sure that your application is as available as possible, and you don't have to do anything you don't have to think about that really. Kubernetes will just spread this out in as an efficient way as possible. So if one node would go down, your application will still be responding, and Kubernetes would also then recreate your pod on the node that is actually up. So you get a lot of resiliency when you run Kubernetes without you really have to do anything about it, which is really nice. So let's talk about the concept here. I mentioned pod. So pod is, you can think of this as your application. This could be a web application. It could be an API. It could be a background processing tool or something like that. So this is basically your container running somewhere. And to get this, when you deploy something and you want to make sure that Kubernetes always makes sure that you have the right number of instances and so on, you deploy this in what's called a replica set. So this one keeps track on how many replicas you want to have. So let's say that we have a front-end application. So then I will create a deployment or a replica set called front-end. And let's say if I now have, for example, five instances, and then I have a cluster that consists of 2 nodes. This would result in something like this, where I have 3 pods running on the first node and then 2 pods running on the second node. Again, if I would now add another node and scale up, Kubernetes will automatically add some new pods on the third node. again, to make it as available as possible. So this would be now the front end, and let's say that we now have a backend as well. Maybe we have a backend API, for example, and so we create another deployment or a replica set called the backend. So now we need a way to communicate. We need a way for the front end application to actually call the backend API. But now we need to figure out how do we actually know where these backend pods are running. So in Kubernetes, we have this concept called a service. So you can think of a service basically as a virtual IP or a DNS. So basically a name that you can use to actually call any of those pods in that replica set that is tied to that service. So in this case, we can create a service called the backend. And this is a simple example of how a service is defined in a Kubernetes YAML manifest. So you can see that we have a kind property there called service. We give it a name, the backend. And then we specify what type of service this is. And this is now a cluster IP. And I'll come back a little bit later on the different types here. But this basically means that we will get an internal IP here in the cluster. So this is typically used for services running inside your cluster that don't need to be exposed to the outside world. But I can still call them if I'm inside the cluster. To specify now which pods should be part of this service, we use what's called the selector. And then we have this key value pairs. So basically in the service, I'm saying that I want all the pods that have the tag called tier or the label called tier with the value backend. They should now be part of this service. So when I deploy my replica set, I will make sure that my pods have those labels defined. And if I add new pods with the same label, they will automatically now be available through this service. So this label concept in Kubernetes is used everywhere. It's a very simple concept, but it's still very powerful in the way that you can configure and track things here. So that means now that the front end could just call the backend by just using the name backend. So for example, if we have a backend web API, we could just do a call to http://backend/API or something like that. And Kubernetes will now route the request. It will do a load balancing through the number of pods that I have. And I don't need to know for example, which node is that particular pod running. I never talk directly to a pod. I just talk through that service. And again, the cluster could scale up, scale down, but I don't really have to care about that. I just call it through that service. So that's great. Now we can talk between the front and the backend, but of course we want to be able to call the front end as well. So the web application, and this should of course be available to the outside world, to our end users. So in this case, we need to create another service. So we'll call that front end. And in this case, though, we'll make one change compared to the other one, and that's the type of service. So the backend service, we use the type cluster IP, which means it's this internal service. But this one, we will set the type to load balancer. And by doing this is actually now a kind of a signal to whoever is hosting our Kubernetes cluster that you should now create a load balancer and configure traffic to be sent to the service. So, and I'll talk more about that later, but if we now run this in Azure, in AKS, Azure will automatically configure a load balancer for us and send traffic to our service. So basically, we will end up with a public IP, and we can now reach our application inside here. And I will walk through an example deploying this later on, so you'll see how this works in practice. But these are the basic concepts in Kubernetes. There's definitely more than this, but you have the pods, you have the replica sets, and you have the services. This is now you can deploy an application and you can configure how to actually the traffic will be routed. So let's talk about the AKS then. So this is the managed Kubernetes service in Azure. It's been around since 2018, and there's a quote there that says this is actually one of the fastest growing services in the history of Azure. So there was a huge demand for this service. So Kubernetes is extremely popular, and again, all the cloud vendors are already supporting this. And this is 100% upstream, meaning that this is not some variation of Kubernetes. This is directly the open source Kubernetes offering. So basically, when a new version of Kubernetes is released, AKS will offer that version within 30 days. I think that's the public announcement around that. So currently it supports the 1.22.6, I believe. But again, new versions of Kubernetes comes along all the time, and AKS is pretty fast of making sure that you can deploy those versions as well. So again, we'll discuss this concept of a cluster where you have the master nodes and you have the working nodes. So in AKS, Azure completely manages those master nodes. You don't see them, you can't access them, and you don't need to pay for them. So the only thing you actually see and pay for are your worker nodes. That's actually pretty good. So you're just paying for the virtual machines, really. So there's no real cost for AKS itself. You just pay for the number of nodes that you're running in that cluster. So the hosted control plane, that's the master nodes. It takes care of doing things like upgrades and patching, and being able to auto scale your cluster and so on. And this is just done for you. If you would peek inside here, what's actually running here, there are these various Kubernetes components like the API server, they have the scheduler, the etcd database, and things running on your nodes, things called like the kube proxy, kubelet, and so on. These are things that you don't really need to know that much about, at least not in the beginning. And if you're an application developer, you can basically just assume that this thing's working. If you are like in charge of actually operating a running AKS cluster, you should be aware of how these like internal components work, because sometimes you might be needed to troubleshoot and look at the logs from these things. But again, all these components are managed by AKS for you. And if you add a new node to the cluster, those components will of course be there automatically. And I mentioned that Kubernetes is portable, so you can run this basically anywhere. You can install it on premise. And again, all the cloud providers, all the cloud vendors offers a managed Kubernetes service. So, and the interesting thing now is that since Kubernetes is extensible, that means that the cloud vendors have been able to plug in their services. So what actually is different, if you run it, in this case, in Azure, there are various services that you can use from your application through the cluster. So, for example, we already talked about the load balancer. So when you create a service of type load balancer, Azure will configure a corresponding Azure load balancing rule for you. But we also have things like the Azure DNS, which can be used when you want to route traffic through an ingress, which I'll talk about later. You have the Azure Container Registry, where you want to push and pull your images from. Kubernetes also supports role-based access control, and you can then do that through Azure Active Directory. And you can also use persistent storage, which in Kubernetes terms is called persistent volume, which means that you can now use Azure files or Azure managed disks as your persistent storage. And all these things is actually completely abstracted away from your application. So you can take the same application, deploy it to another cloud, Kubernetes, and you basically just change the configuration file specifying what type of storage you want to use. And this is really some of the power with using Kubernetes like this. So creating a cluster, you can do that in various ways. You can do that, of course, through the portal manually, and I will just actually quickly walk through that just so you have seen it. You can do it through the Azure CLI, and so basically these are the only two commands that you need to use. Of course, you can and will probably send more parameters like this, but this is like the bare minimum. So you create a cluster in a specific resource group, and then you can download the credentials to your local machine, and from there on you can continue operating it through the Azure CLI or through the Kubernetes tooling actually. And the third way is to do this through ARM templates, and there's more options here as well, of course. now you have Bicep, but you can also do this from, for example, Terraform, Pulumi, and so on. And this is typically what you would do through some kind of deployment pipeline when you deploy this cluster. So let's just switch to the Azure portal, and let's just quickly walk through like how it actually looks when you create an AKS cluster. So I already have 2 existing clusters here, but let's create a new one, and I will just walk through here, and we'll see some of the options here that's involved when you actually create a cluster. So first up, we will just create a resource group. Everything in Azure needs to be in a resource group. Nowadays, when you create a cluster, you can actually select from a few preset configurations just to make it really easy. So you can see that they're kind of offering 5 different preset configurations here, and you can see a kind of a comparison table here. And this is really about what is the intended use of this cluster, and they kind of offer a good setup for that. So if you're using, for example, a dev testing, you can probably use a smaller size, and then you don't need features like auto scaling and availability zones and policies and so on. So you basically just want a simple cluster that is as cheap as possible. But on the other hand, if you have like hardened access, then you probably want to make this is for large enterprises. Then you typically want to have a good sized machine size, and you want to have all these things like auto scaling, potentially do private clusters, so it's not accessible to the outside world, and so on. So this is just an easy way to create a good setup for you. And of course, these are things that can be added and modified later on. You give it a name. Let's call it Cloud Native. I'm going to talk a little bit about availability zones later on. So this is about availability. Down here, we can then select the node size. So again, here I can select basically the amount of resources available on my virtual machines inside these worker nodes. And this is called a node pool. So a node pool is basically a set of machines, and you can actually have multiple node pools. You can select if you want to only manually scale your cluster, or if you want to auto scale it. And typically for your standard, like the things running in production, you typically want to have auto scaling here. And if you do auto scaling, you can specify here how like the minimum and the maximum of nodes here. So one node is really not the. If you want to run this in production, you typically want to have at least like 3 nodes running here to make sure that you have a good SLA. But again, these are things that you can configure differently, and you can also change this later on as well. So as I mentioned, we can add more of these node pools, and let's walk through to authentication. So when you create a cluster, what you typically want to have here is to assign a managed identity to it. You can also refer to an existing or create a service principal, but either way, this is the identity of your cluster, and this is then used when you need to access other resources within Azure. So a common example here is you always need to be able to, for example, reach the container registry to actually pull the applications, or pull your container images from that container registry, and then your AKS cluster needs to be able to authenticate that. So this is the identity that will be created, and you can then use that later on. Kubernetes also supports role-based access control, meaning that you can then, when you do management tasks in your cluster, you can define things like administrators, readers, log readers, and so on, and then you can refer to existing Azure AD groups, for example, so you can make sure that only the administrators have the necessary rights to do admin tasks on your cluster. We have networking, and this is a big topic, and I won't cover everything here, but basically specifying what type of networking that you want to use. There's multiple options here. Specifying the type of load balancer. Here we could also enable a private cluster, meaning that this will now only be available inside your virtual network, so it won't be exposed to the outside world. So this is great for certain type of workloads that doesn't need to be exposed to to the public internet. On the integrations, here we have the connection to the container registry. So since this is a very common thing to have, you can actually make sure already here that the necessary permissions is set up for this cluster to be able to fetch images from any of your container registry. In here, we can also connect this to Azure Monitor and to an existing log analytics workspace. So I'll talk more about that later, but everything, all the diagnostics and logs from your cluster and your application in the cluster will then be routed into this workspace, and then you can get a lot of insights and troubleshooting by using Azure Monitor. So that's pretty much it, and now we can just hit create and wait a few minutes, and then it would create the cluster. So let's instead of waiting for that, let's just look at a cluster that I already created, and I'll use for the demo later on. So this is you can see here that I created it before with the one node pool, and we have the 1.21.9 version here, and we can see a lot of the different options here that I talked about before. We have some functionality here for actually peeking inside of this cluster, so we can look at what's actually running in here. So if you go to the workloads, we can see the things running inside my cluster. So here we actually will be seeing a lot of system things. So all of the Kubernetes kind of system functionality actually runs inside of this cluster as deployments, as pods. So if I drill down, you can actually drill down all the way down to my pods. And again, I see a lot of system things here. So if I, for example, filter on the namespaces here, we can see that there's a lot of system namespaces here. And the default one is like it's always available in a cluster. And here you can see it's completely empty because I haven't deployed anything to this cluster. So that's what we're going to do in a few minutes. And then we'll see that this will pop up here. So let's just go back to the slides, and sorry about that. Let's go back to where we were. So before we deploy the application, we should just talk a little bit about the networking, and I kind of already mentioned a few of these topics because they are important to know. So as I showed you before, Kubernetes uses services to kind of logically group a set of pods to make it very easy to access them and to do load balancing between them. So again, the cluster IP, this is the internal IP address that you can use within the cluster. So this is this is the most common one for all of the kind of the private services that don't need to be accessed from the outside world. There is another service type called node port, which is not that commonly used, but it's basically one of the ways to get external traffic coming into your application. But the more common one then is to use the load balancer, which will then create and configure an Azure load balancer resource. So you configure an external IP address, and it will connect the pods to that load balancer backend pool. And so basically, if you look, this is from the documentation site. If you think of a cluster IP, it will look like this. You have some internal traffic hitting that cluster IP, and then you have a certain number of pods that you will get the traffic routed to. So basically, it will balance or direct the traffic to any of these pods in a load balanced way. And so if you scale out or scale down the number of pods, the traffic will be routed appropriately. The node port, again, this is a bit special, where you can map a specific port on your nodes to a specific port on the pods. But this is a pretty static setup, and again, not very commonly used. So again, the more common one is to use the load balancer, in which case the provider or the host of the cluster will then configure a load balancer for you. So if you run this on premise, you need to have some other type of load balancer to actually do this for you. In the cloud, this is just done automatically for you. So again, now you can have incoming traffic from the outside world hitting the load balancer, and the load balancer will then direct traffic to either of your nodes, and again, then to one of the pods behind that service. So load balancers are great, but they are basically, every time you create a load balancer, you get a public IP. And when you have many services running, if you have many public APIs or endpoints, you typically don't want to create a new load balancer and then you get a new IP for all of these endpoints. So another very common thing to use in Kubernetes is called an ingress. So ingress, they work at a higher level in the HTTP stack, which means that instead of just routing through an IP, it can actually do routing based on the HTTP endpoint. So as a simple example here, if you have two services running in your cluster, you have a blog service and a store service, you can then do some routing rules or ingress rules, specifying that if I go to myapp.com/blog, the traffic should be routed to the blog service. And if I do /store, it will be routed to the store service. So now you only basically just need one public IP, and then you can set up these rules to actually do the routing for you. So this is very powerful, and there's many different options you can use to actually implement this. So where the most common ingress controller is probably Nginx, but there are other ones as well that will basically implement this ingress functionality for you. And I should also mention the kubectl. So this is the command line tool that you will be using when you work against a cluster. So it doesn't really matter if this is an AKS cluster or if it's running on premise or anywhere else. You will then use the same command line tool for running commands against the cluster. And you can also use this to deploy applications and so on. Even though, like in a real case, you would do that through some deployment pipeline. But still, you can do a lot of these things from your local machines as well, which I will show you now. So I showed you that the cluster before, the AK demo cluster here. And so let's deploy something to it. And I have an old sample application that I typically use in various demonstrations. It's called the Quizbox or Qbox. So it's a simple application for simple quiz application. So it basically consists of a front-end web application. We have a back-end web API, and then in this case, I have actually a SQL server storage here. And this is a source code for it. And when I run this locally, I typically use Docker Compose. So if you used Docker before, you probably know Docker Compose is a way to easily define and run multiple containers on the same network. So this typically looks like this. I have my web application, I have the API, and I have the database. And so the web and the API, these are applications that I build myself. This is the source code for it, so I can build and run it. But the database, I'm actually just referring to the official SQL Server for Linux container image that is available on the Microsoft Container Registry. And I just pass some information to it, like the password and so on. And so, just to show you running this locally, I have it down here. So the web application just looks like this. I can start a new quiz, answer some question, and post some score back here. So this is the application. It's very simple, but it consists of a few moving parts. So this is the application that I want to now deploy into my cluster. And this is a containerized application, which means that when I build it, I get container images. And I already published those images to the Azure Container Registry. So it's already there. So what I need to do now is to create these deployment manifests that I showed you on the slide before. And I have already defined them here. So I have a deployment manifest for all these things. We have the front end, the back end, and the database. So let's start with the database. And if you remember from the slide, we have this deployment manifest. So this is where you specify a deployment of a container image. In this case, this is a SQL image. So again, this is not something that I built. I'm just going to use this as a storage. So I'm specifying the image. I'm giving it a name and specifying things like which port should it use for the traffic. And I need to set some environment variables. So this, if you're looking at the documentation for the SQL Server image, you have to specify like this accept EULA, and you have to give a password for the SA here. So this is a deployment, and then I want to be able to actually communicate with this database, with this pod. And to do that, I will now create a service, so you can actually define this in the same file. So again, you remember from the slide that I showed you before, we specify kind service, we give it a name, and that means now that when I deploy this, I will be able to talk to this database through the name DB. That will now be the DNS entry inside the cluster. And I specify the port again, and the type cluster IP. Let's say, just to take a quick peek on one of these, let's look at the backend. So this one is pretty much identical. The only real difference here is that I'm now pointing to my own container image here. So this one is now located on my Azure Container Registry called the Jakob. And we have the image name and the image version. And again, we create the service with a cluster IP. However, with the front end, the difference here is that we specify a load balancer instead. So let's deploy this then. So I think we are in the folder here, and so now I'm going to use the kubectl command line here, and you can see that we have a lot of options we can use here, lots of commands. So I do have an alias for kubectl, just k, so it's the same thing. So when I type k, it's actually kubectl. It just saves me some typing here. So I'm going to start by deploying the database. So I'm going to run the kubectl apply, and then pass the file name. So this is now applying the configuration, and you can do this over and over again. And this is an idempotent way of deploying things. So if Kubernetes now notices that this deployment doesn't exist, it will create it. If I apply it again, nothing will happen. So if you run this in the pipeline, you can just run these commands over and over again. So let's do a kubectl apply dbml, and you can see now that it says deployment created and service created. So we have both these things defined in the same file. So now let's do a get deployment to see what we have now. And now we actually have then one deployment called the DB, and it says that we have one replica that we wanted, and there's one replica running now. That's a good thing. So it's already running now a database here. And we can also look at the pods. So we can see now the name. So this pod is now running on any of my nodes here. And so you can also do get nodes, so we can kind of see what we have in the cluster here. So we can see we actually have 4 nodes here, and the last one is a little bit special. I will come back to that later. So, but otherwise we have 3 nodes running on the desired version here. So which means that this pod is now running on one of those machines. I'm not really, I don't really know which one. I could check it out, but it's not really that important either. But for example, I can also now get the logs from this pod, and let's do that. And now we can see actually the logs from that database container or that database pod running inside a cluster. So that's cool. So let's deploy the backend as well. So we'll do another kubectl apply, and we'll pass the backend now. So now it will deploy my backend web API that actually talks to that database. So let's check to see what we have. That's great. So now we have the database deployment, and we also have the backend deployment running now. You can see the age here. It specifies how long this has been running. Let's also see, we can check the services. So we can do a get SVC. This now shows me the existing services. So you'll always see one called Kubernetes. So this is like a system service. So you can kind of ignore that one. But now you can see also we have the API service and we have the DB service. And here you can also see that this is cluster IPs. So that means these are internal IPs in the cluster. They're not exposed to the outside world. However, if I have permissions, I can actually access them through a kubectl proxy. So this is actually something you can use to actually access or troubleshoot or test services, even though they're running inside a cluster. So I can do a port forward, which says that for this particular service, I want to forward all traffic from my own machine on port 8082 to the port 80 inside my cluster. So when I run this, it will actually set up a listening proxy on the port 8082. And if I now open a browser and go to that port, that traffic will actually be sent now to my API. And so I know that I have an API endpoint here called API category. So if I run that, we should get some data back. So this is now I'm actually hitting my API endpoint inside the cluster. That API then speaks to the database and returns the different quiz categories. So that's great. I know that the application is running. But I want to deploy the web application as well. So let's deploy the last one. And now I'm doing this step by step. I could easily deploy all these files in just one simple command here. But this is just to show you kind of step by step here how this actually works. So now we deployed the front end, and one of the differences here is that this is now a load balancer type of service. So if I do a get service now, we can actually see now that the front end type is load balancer, and it does have a cluster IP as well. But in addition, it has an external IP, which the other one doesn't have. And this is the difference then, because now this is now configured in Azure for me, and that means that I can now use that IP. And boom, I'm now accessing my web application through the public internet, running inside a cluster that I just deployed. And just to show you that this is not like super magic, I'm actually going to show you that load balancer. So if you go to your Azure subscription and look at the resource groups, I have this AKS demo inside here. This is where my Kubernetes service is located. But you also actually, when you create a cluster, you get another resource group that contains all of the gory details, so to say. So inside here, you actually see things like your virtual machine scale set, that's your nodes, the various identities for your cluster and so on. And you can also see your load balancer here. So it's just called Kubernetes. So if I open up the load balancer to kind of peek inside here, we can look at the front-end IP configuration. And here we can actually now see, if you remember, you can go back to here. You can see this IP here, 20.82. You can see this is now the same one as this one. So what actually happened when I deployed that service in Kubernetes, that triggered the creation of a front-end IP configuration here. So it actually added this on demand. And if I would delete that service, this configuration would then be removed. So this is what you get when you deploy a load balancer service in Azure. If you would do this in, for example, in the Google Cloud, they would create and configure a Google load balancer for you automatically without you having to change anything in your application. Okay, so that's cool. Now we have the application running. Since this is Kubernetes, there's a lot of tooling out there that you can use for various topics. There are many existing tools you can use to actually kind of peek inside your cluster. So this is one called Lens, which is a free tool. It's great for administrating and peeking inside your cluster. And we can also do some things from here. We could also do this from the command line, but let's see. Again, we have 3 deployments running here: the backend, the front end, database. And we can see that each of these deployments now have one pod running. So one thing that I can show you now is the resiliency that comes with Kubernetes. So I specified that I always want to have one replica, one instance of each of these deployments. So let's see what happens if I now go in and just brute force delete one of my pod. So if I just delete the front end pod here to simulate that it crashes, we can quickly see now that it's terminating, but immediately at the same time it says pending here, and now again we have a new front-end pod that has just been running for a few seconds, and this is part of the Kubernetes. It's called the Reconcile Loop. So it will always make sure that your deployment is fulfilled. So again, I specified I want to have one instance. So that means that if I remove one instance, the Kubernetes will now actually create it for me. If I would add another instance, Kubernetes will actually now remove it for me if I haven't specified otherwise. So it will always make sure that you have the correct number of instances here, or replicas. Of course, what I also could do here, I could, for example, scale up now. Let's say I want to scale out my front end. I don't want to have just one instance running here. I want to scale up. We can do that from here. Again, I could do this from the command line as well. And of course, this is static scaling. So typically you want to have auto scaling, but let's just see what happens here. So let's scale up to 5 instances. And you should see now that very, very fast, we need to now have 5 pods running here. If I go over here, I can see that we have 1 backend, 1 database, but now we have 5 front ends. And these will now be distributed across the 3 machines. You can see on the name here at the end there, we have 001, 000, 002, 002, 001. So basically, Kubernetes have distributed these across 3 machines in a as good way as possible, really. So you can see now how quick it is to deploy, how quick it is to scale. And I want to show you one more thing. Let's do what's called a rolling upgrade here, just to show you some of the power and the functionality within Kubernetes. So let's say I want to upgrade to a new version of my web application. So now I'm running, I think it was the 2.244. Let's peek inside here. Yeah, so I want to upgrade it to 2.245. Now, when I do that, I want to do this in a way that makes sure that the end users aren't affected. And that means that I want to gradually move traffic from the old ones, from the old version to the new version. And I don't just want to remove the old version first and then create the new versions, because that will create downtime. And in addition to that, I want to make sure that my new version is up and running and warmed up before it hits traffic. So typically when you create a new instance of your web application, it won't be super quick to access right from the get-go, because it needs to kind of maybe load some caches, it needs to do some compilations and so on. So typically you want to deploy the new version, and you want to warm it up and make sure that it's healthy, and then send some traffic to it. And this is exactly what Kubernetes lets you do very easily. So to show you this, I'm going to upgrade now to 45 in my front end here, YAML. I want to keep 5 replicas here. And I'm going to now uncomment some things here that I will explain. So first up, I can now specify this a strategy. This is now how you can specify how you want to deploy to Kubernetes. And the most common one here is called rolling update, which basically means that when you do an upgrade, it's going to create a new version, deploy the new container version in parallel with the existing one, and then it's going to remove the old version. And then you can configure how that should work exactly. So for example, you can specify that how many new versions or new instances should you create before you take down the old one. And this is kind of depends on how much resources you have in the cluster and so on. And also how many of the old ones should be unavailable. So basically this means that it's going to create one new one, and then it's going to remove one of the old ones until they're all done. And at the bottom here, I also added what's called a Readiness Probe. So Kubernetes supports different types of probes, which basically is an endpoint in your application that Kubernetes can check for health. So in this case, I specify a health endpoint in my front-end web application that Kubernetes can now call, and I specify how often it should call it. So basically, this setup means that first Kubernetes will create the new pod. It will wait for 3 seconds, and then it's going to periodically call this service every 3rd second until it responds that it's healthy. And when that happens, then from that point on, traffic will now be sent to this new version. And this now makes sure that the end users doesn't experience any downtime. So we get zero downtime deployment here. And I'm just going to show you this health endpoint because it's kind of a fake thing that I implemented just for demo purposes. So this is the health endpoint, and what it does is that it actually waits for 20 seconds. So if you call this endpoint during the first 20 seconds, it's going to return 500, an error code. But after 20 seconds, it's going to return 200. So basically, this simulates that it takes around 20 seconds for this this API to be kind of healthy and warmed up. So with that out of the way, let's deploy this. So let's just make sure that I save this one, and let's just reapply the same configuration here. So I can just do apply frontend, and now Kubernetes will then just notify or detect what's actually being changed here. So the service wasn't changed, but the deployment was actually changed. Now to see what happened, let's go back to the lens here to see what happens now. So now you can actually see that it's terminating some of the old ones, and it's going to create new ones running here. And you can see there are some little warning signs here, and the text says Readiness Probe failed. And that's because my endpoint, during the first 20 seconds, it's going to return an error. And that means that Kubernetes will continue to do so until it gets to 200. And once it gets that, then it's considers it to be ready, and it now moves on to the next one. So during maybe, it takes maybe now 1 minute to deploy all of these 5 pods. This is now a gradual rollout. So if I now hit the application, I will, sometimes be routed to the old version and sometimes to the new version. And after, around a minute, all of the new versions will be running, and there will be no noticeable or no visible downtime for the end users. Again, this is really some of the just part of the power of Kubernetes that you get with this platform. You can very easily now implement things like zero-time deployment and so on. So now you can see we have all of the 5 pods running. You can see on the edge here that they have. This is now the new version running, but this was now done in a rolling update fashion. Okay, so let's go back to the presentation. So we were here. So let's just talk a little bit about some more advanced topics. So now you show kind of the basics, how you can create a cluster, how you deploy applications to it. And of course, there's a lot of more details, a lot of more knowledge that you can dive into. But let's talk about some of the things that you typically are specific to Azure Kubernetes Service. So the first one is scaling. So there's different types of scaling with AKS. So the first one is something called horizontal pod autoscaling, HPA. This is really part of Kubernetes itself. This is a core functionality that any Kubernetes cluster will provide. And this is the way that this is how you scale out your application inside your existing cluster. So basically, when you apply this or when you configure this, this means that you can now, depending on the load, you can now scale out the number of pods here. So for example, if you have a high CPU load, you can say that I want to auto scale the number of pods for my deployment up to, for example, eight instances. And when the load goes down, you can then go back to the original number of instances. So that's how you can scale out within the cluster. Then you have the cluster autoscaler, which means that you will eventually fill up the resources of your existing nodes. And when that happens, you want to be able to scale out, basically saying, I want you to create more nodes, more virtual machines. So this type of scaling is not as fast, of course, because it takes much more time to create a new machine, a new node, compared to just creating a new pod. But AKS will do this for you, depending on how you configure it, and add more nodes, and then it will distribute or add pods to that node, and basically giving you more resources and more power. So let's just quickly show you how the horizontal pod autoscaler actually works. So again, you have a deployment that is controlling a certain number of pods. And then you deploy the horizontal pod autoscaler, or you can configure it. And you can do this using the kubectl command. So here you're using the autoscale command, and you're specifying which deployment you should scale. And then you can specify some limits here. So in this case, I'm saying that if the CPU load of this deployment is over 10%, I want you to scale up to a maximum number of 10 instances. And again, when the load goes down, you can again scale back to 1 instance. So to to get this information, the autoscaler will read from what's called the metric server API. So everything running in your cluster will report its metrics to the metric server API, which can then be used by the horizontal pod autoscaler to then scale up or down your deployment. And to make sure that this works as expected, you need to define the resource limits, or actually requests and limits on your deployments. So I didn't do that on the examples that I showed you, but if you want to do autoscaling, you want to make sure that you have this resources definition in your YAML manifest that specifies how much resources you need. That's the requests. And then you can also set a limit to it. In this case, the CPU. So this information can then be used by the autoscaler and by Kubernetes to configure also where to put these pods, so you can actually use the resources of your nodes as efficient as possible. I should also mention CADA. I talked about that last week, actually. So because the built-in horizontal pod autoscaler uses CPU and memory for determining when to autoscale, and that's great for a certain type of workloads. So, for example, a web application or some processing application can be scaled quite efficiently by that. But then you have all this type of event-based applications where the number of events are more interesting in depending on how you want to scale. And this is what the CADA does. So CADA is an open source project that you can easily deploy into your cluster, and it lets you scale your application based on various services, many of them event-based. So you have a long list there to the right. So, but like a common example would be to, for example, check a national service bus queue, and saying that if you have some processing application that consumes events from that queue, you want to autoscale that if you see that the number of messages on that queue increases rapidly. And this is something that the built-in horizontal pod autoscaler can't do by itself because it doesn't really know anything about your queue. So this is what CADA brings to the table. And that just means that you can now say that if the number of messages on my queue goes above, for example, 10 messages, I want you to scale out my consumer application so that I can be able to more efficiently process those messages. So again, if you're looking into scaling things in Kubernetes, check out the CADA project to do event-based scaling. The last part is cluster autoscaling that I talked about. So enabling this is very simple. You can see that when I created it in the portal. This is how you would enable it when you deploy it through an ARM template, just specifying the minimum and the maximum. And I just included a slide here that actually shows you when I did this a while back to kind of demonstrate cluster autoscaling. And so what you can see here on this top left here, you have a graph showing you the number of pods running, and down here we have the number of nodes. So what we can see here is that at this point we started to have increased load on the cluster. So the horizontal pod autoscaler started to scale up the number of pods, but then it hits a limit here in where it couldn't create more pods because of we ran out of resources. This is the same time we can see that we actually get some pending pods here that can be created. And this is now a signal then to the AKS to scale up our cluster from 3 nodes to 4 nodes. And as soon as that happens, you can see that it could actually create the last pods here until we were done, and then we were running for a while, and then the load decreases, and then the HPA scales down again to the original number of pods, and then after a certain delay, which is configurable, the cluster will then scale down again. So these two things really work hand in hand, that you can first scale out inside your cluster, and then you can have the cluster autoscaler to add more nodes to your cluster. And then eventually you can scale down again, so to make sure that you're not paying more money than you should. And the last part, type of scaling with AKS, is actually serverless scaling. So in addition to this, we have something called virtual nodes. and you actually saw one of those before when I showed you the nodes in my cluster. So, and this is a kind of a cool concept. So the idea here is that creating new nodes does take some time. It typically takes a few minutes to add a new node to your cluster. So what Azure or AKS brings to the table is what is called a virtual node. And this is actually based on the Azure container instances that I talked about before, the serverless containers. And when you install or when you configure virtual nodes for your cluster, that means that you can now scale out to new nodes. And for Kubernetes, this looks like regular nodes, but under the hood, it's actually a container instance. And they typically start much, much faster, typically around like 10 or 15 seconds to create a new node. So this is great for doing like a burst load when you have all of a sudden have a lot of load on your site, for example, or some order processing. You can scale out using the virtual nodes instead. And so this is actually based on, this is also an open source project called the Virtual Kubelet, which basically just implements the API of a node. So for Kubernetes, it just looks like a regular node, but it's actually behind the scene creating Azure container instances instead. So this is quite a cool concept that can really help you in certain cases and also save you some money in the end. So actually, just to quickly again show you what I mean by this one, if I go to this one and grab the nodes again, you could see this one. So we have the 3 regular ones with that version, and then you have this special one here called Virtual Node ACI Linux. So again, for the kubectl here, it looks like a regular node. So it reports back this is a node. You can actually see that it has a completely different version, which would not be possible with the regular node. All nodes in a cluster must have the same version. So this is an example. So I could potentially now deploy, if I would deploy a pod to that node, it will actually under the hood create an Azure container instance instead with that container image. So another thing that's of course very important when you're running things in well anywhere is monitoring. So with AKS or actually in Azure, you have this kind of umbrella service called Azure Monitor. So basically everything running inside Azure, including your application, can and will send data to Azure Monitor. So Azure Monitor consists basically, if you simplify it, of 2 stores. You have the metric store, which contains things like CPU, memory, and those kind of things, events. And then you have a log store where all of the other like text-based or things coming from, for example, from your application, they are stored in a log store. And once you have this data, and it could then be sent from your applications or from the Azure resources itself or from the virtual machines that you run on and so on. So everything goes into these stores, and then you can use a lot of different things here on the right to kind of work with that data. So typically you can visualize it using dashboards and views. You can use Power BI, for example, to create reports. You can analyze it. You can integrate other services into it, and then you also have this kind of specially built insights applications inside Azure that just helps you to analyze and understand this data. So one very common example of that is the application insights, which is like an APM solution for your application to show you all the relevant information about how your application is doing, if it's healthy or not, how many users do you have, how is the performance, and so on. And then there's a similar one for containers, which basically is for AKS. So it will show you a lot of information about the AKS cluster. So, and that's of course the one that we're talking about here. So again, the information coming here is from both of the Kubernetes cluster itself and the operating system that runs there, but also from your containers. And it's going to collect your logs. It's going to collect memory and processor metrics through the metrics API, written to the metric store, and then you get the logs to the log store. And so let's actually go back to the cluster and let's head over to our AK demo cluster here. And if we scroll down a little bit here, we have beneath the monitoring, we have the Insights tab here. And inside here, we can now see kind of the container insights solution in practice. So here we can see some nice overview information, such as the node CPU memory. We can see the node count and how many pods are currently running. And this is now from the last 6 hours. So we can get down to the maybe last 30 minutes and so on. And we should, for example, here we can see that we increased the number of pods. So this is basically when I deployed our application, 10 minutes ago. So we can see that the pod count actually increased. We saw maybe some increased utilization here. And again, here we can now drill down all the way to, this is on the cluster level. We can drill to the node level. So again, we can see that we have 3 regular nodes that reports a lot of metrics here. And then we have this special node, which doesn't really report anything because it's a virtual node. But still, it shows up here because Kubernetes thinks this is a node. So from here, I could also drill down and see what's running inside that node. And I can do it here as well. I can drill all the way down to the containers running. And so now you can see that we have a lot of things running here. So let's filter, for example, on the default namespace. So now you can see only the things running here. So this is for the last 30 minutes. So we can see the front-end pods running here. There's actually multiple versions of everything here. And so, for example, if I check the DB pod here, I can see information about this container. I can actually see, any live logs coming from it and live events. So I can really drill all the way down into the each individual container inside this insights here. And of course, in addition to just watching information like this, I can also set up a lot of alerts. So there's a lot of ready-made alerts here. So things like if the number of failed pods increases, if the CPU load of the node is greater than 80% and so on. So these are like common ones that you can just enable by switching this thing here. And automatically you will now be alerted anytime that this alert is triggered. But in addition to that, all this data is now sent down to the log analytics store. So if we go to logs here, we can actually now see all the information that is being sent from the cluster into this log store. So here, for example, we can see the container logs. So if I just do a run on this one, we can see all the information that comes from all of the containers running in the cluster, including, of course, the system pods here. And we could also, let's just try one of the pre-built queries here. For example, let's look at the container CPU, or maybe see how we can do this one.
Hey, Jakob.
Hey. Yes. Hi.
I'm sorry. We need to be a bit time respective. We are already 15 minutes over time. So yeah, just.
Oh, okay. Sorry. Yeah.
It's okay.
Thank you. Yeah, I'm almost done actually. So.
Okay. Thanks.
So thank you. So again, this Azure Monitor. This is where you can drill down on information, setting up alerts, building dashboards, and so on. So basically all of the information will be available there. So we covered this already. So the last thing I just want to quickly talk about is the availability of AKS, and this is really built on the concept of availability zones. So within each region you have multiple data centers called availability zones, and if you deploy your cluster with availability zone support, it means that it will distribute your nodes across these data centers. So it will typically look something like this. If you have 3 nodes, you can now deploy each node into a different data center automatically. Again, making sure that your cluster is as available as possible. So in the case of one complete data center will go down due to some natural disaster or some problem, your application or your cluster will still be available because you have nodes running in the other data centers. And this is very easy to configure. It's just done automatically. And in addition to this, you can actually set up clusters in multiple regions. For example, a failover cluster. So you could have one in Europe and one in the US, and then you would put something in front of these clusters. So this could be Traffic Manager or the Azure Front Door, and send typical traffic to your primary one. But if that one would go down, the traffic will then instead be sent to the secondary region. So that was actually the last one, and I have some links, and I think Erica posted the links to the chat. So these are some learning material. So the doc site on Microsoft for Azure AKS, and the learning path, and then there's also a great learning module where you can really learn by kind of a step-by-step thing that you can follow yourself. So with that, I just want to say thank you for attending my session. Again, if you're living in Sweden, you can use this barcode to get some. We'll send you some cool stickers and have a chat. And just to mention again that this was the last session of the Cloud Native track, and all of these sessions was of course recorded, and you can see them over at the Microsoft Reactor YouTube channel. So again, with that, I just want to say thank you, and sorry for spending a little bit more time than I was intended to. It's just so fun.
I know, and that's okay. But thank you so much for being with us today. And yeah, I mean, it's hard to stop when you have good content, right?
Yeah.
We do have a few questions. I don't know if you have answered them as you went, but let's just have a quick look at them. Let's see here. Let's go back. Here, I'm putting this. Do you see the screen, Jakob?
Yeah, I'm just trying to find my way back to StreamYard. Yeah. So let's see, what was the question? Do we need to create routes, or is it provided by AKS?
Yes.
So I'm not completely sure what he means by routes. Maybe it's for the ingress traffic. So I'm not exactly clear about that question, to be honest. So let's see if there was an. Could you give a recommendation for a development tool like Docker Desktop that integrates well with AKS? So yeah, I mean, Docker Desktop is not really a development tool. That's what you can use to actually run and build containers locally. There are other options there, like Podman, for example, that you can use also to work with Docker locally. And also there are some great tooling. For example, VS Code has a great extension for Kubernetes. Let's just actually quickly just show that if you have VS Code installed and you search for Kubernetes, you get this one from Microsoft. There's other one as well, but this also really helps you to work locally against Kubernetes, and you get kind of insights into it, and just makes it easier to work with Kubernetes-based applications locally. So the last one was, what are the ways to execute C database scripts? Well, to seed your database, that's not really up to Kubernetes. That's up to your application. And of course, there's multiple ways to seed your database. Things like doing entity framework migrations, for example, or using SQL DAC packs, depending on what type of database you have. So it's not really a question specific to Kubernetes in that case. So it's a little bit out of scope, maybe. So was that the last one? I think that was the last question.
Yeah. I think so. Yes.
Yeah, and you sent the links there as well. That's good.
I did, yes. Yeah, they are the same links. I just made them shorter.
Yeah.
So yeah, with that, I just want to say a huge thank you for wrapping up this this track and this season, in fact. And we are going to continue with season 2 in March. So keep your eyes out on your meetup pages, where in the region that you are viewing from, because they are going to be published very soon. So yeah, thank you very much, and I hope to see you soon. Jakob, thank you. Thanks a lot. Have a nice evening. Thank you. Bye.
Bye-bye.